So suppose you are given this function. And you are asked to find the value of f inverse of 3. So in other words, you have to find because of this property that f not, sorry, f composition, f inverse is identity. You have to find this. So this is some number, let's say x naught. So I do this. And this gives me 3. So this is saying when you have to find the value of f inverse at 3, in fact, you are looking for the number x naught which gave you 3. This was our principle that you have x-axis, y-axis, you have some function, and the job of the inverse is given some value. So like over here, 3, read off the x value, which I'm saying over here is x naught. So which x naught gave us this 3? And since f is 1 to 1, since we are talking about inverse, as f inverse exists, so f has to be 1 to 1. That means there's going to be only one number which gives us this. So if I can find that one example which will give me a 3, then I'm done. I don't need to show its uniqueness or anything like that. And it's quite obvious that what it would be. Well, this was meant to be x5. It's obvious what it's going to be, because if I choose x equals to 1, then f of 1 is 1, 5 plus 1 cube plus 1 is 3. So that implies that is the unique number which will have f inverse giving us 3. Let's take another similar example. So suppose you are given f of x as 3 plus x plus ex, and you have to find f inverse at 4. So again, you are looking for, look for some x so that f of x naught is 4. That's all you want. Now I can just guess it from here, because if I choose x is equal to 0, then I'm gonna have f of 0 is 3 plus 0 plus e to the 0, which is 1, So it gives me 3 plus 1, 4. So that means F inverse of 4 is 0. Without even finding the inverse, I can tell that. Let's take some more examples. Let's do this. So you're given this graph. This is 0, 1. Each box is a unit. 1, 2, and so on. And you have this graph. Crosses it here, crosses this here, and goes up to here, like this. At -1, and crosses the 0 around here. And then you have 1, 2, 3. Like this. Now you have to find, so this is -3, and this is -1, and this is 3. So what is the domain? Domain and range of, this is the graph of F. What is the domain and range of F inverse? So domain of F inverse, first of all, this is 1 to 1, just by it looks like that. So domain of F inverse is this range. So this is -1 to 3. And range of F inverse is just the domain of this. What is the value of F inverse? We are given the graph of F, but we have all the information, as I said in class, about F inverse in this graph. What is the value of F inverse at 2? So what does the F inverse does for you? You look for the Y value and see which X value it came from. So you're given here this value 2, and you're just going to look where it came from. It came from 0. Similarly, you can ask, what is the value of F inverse 0? So again, you just go to the 0 value of Y and see which X it comes from. So it's something like -1.7. Now, let's consider this. So suppose you are given f of x as 4x minus 1, 2x plus 3. Find the inverse function. So all you need to do is write this equation and solve it for x if you can. In many cases, you won't be able to do it, but you just have to look for some clever tricks. If you can find, good. Otherwise, you don't know the inverse. So I can do this in this case. And now what I can do, so this is a y. I can bring it here and solve for, I want to separate the x's. So I can combine the x's on one side. So x is 3y plus 1 over 4 minus 2y. And that's the inversion. That means I can interchange them now. Let's call it a new function. Y is equal to g of x is equal to 4x plus 1 over 4 minus 2x is the inverse function. What else I can do? Well, take another example. Invert this. So again, write like this. If you have an exponential, you want to solve for x, always take a log. That means x is 1 plus log of y over 2. So this means y is equal to g of x is the inverse function. Now, let's consider this. Suppose you are given this graph. You have this point and you have this point. And then you have this point. And then you have this point. So this is 1 minus 1 minus 1, and this is minus 1 minus 2. This is 2 2, and this is 3 3. And this is not minus 1 minus 1. This is 1 minus 1. Your job is to draw the graph of F inverse. So all you have to do is, first, what we can do is invert, reflect along x-axis. So when you reflect along x-axis, nothing happens to the x value, and y value, it gets reversed in sign. So this minus 1 minus 2 will become minus 1 2. This guy becomes this. 1 minus 1 becomes 1 1. 2 2 becomes 2 minus 2. And 3 3 becomes 3 minus 3. So you have this graph. Now you have to rotate it. So when you rotate like this by 90 degree, this guy is gonna come over here. And what you can do under rotation, angles are preserved. So you can draw these perpendicular lines and they will remain perpendicular. And you can just figure out where does this point go. So this point comes over here. And this perpendicular lines, it preserves the angle. So this becomes a line going down here. And this point is now mapped here. Similarly, you can draw this perpendicular line and figure out where does this point go. This point comes here. And this perpendicular line remains up. So it becomes this. Take this, draw this perpendicular line, see where does this point go. This goes here. And this remains perpendicular and remains at the same distance. Distances are also not changed under rotation. So this comes over here. This point goes here. So this remains at 3. It remains this. So this blue is the graph of F inverse. And you can check visually that if I draw this line, y is equal to x line, then the graph of F and F inverse are symmetric around it, because it's also a reflection along this y is equal to x line. And this is a check that this purple and the blue are inverses of each other. So any question? So those people who are saying that this should be ln or log e. So convention, I don't know if I emphasized it in class or not. I'm just so used to, well, everyone after you have entered university, or at least you are in mathematics department, this is a convention. When people write log means log to the base e, or as what some people call ln, natural log. So log for us, for me, for everyone in maths department, and for anyone taking this calculus course, I don't know if the book follows this. Book still writes it ln, but whenever you see me writing log without any base mentioned, that means it's a log to the base e, or what you have been calling ln. So I'll always write it as log because every mathematician writes it like that. So is that clear? This was a question in the chat. Let's take another example of graphing. So suppose you have this 2 and 4, and the graph is like this. This is the graph. Sometimes my pen gives me trouble. I don't know why. Maybe it's near some magnet. Let me remove my phones and other computers. So this is the graph. You get the idea. It's touching it at 2. Now, when I reflect it, I'll get this. And then I have to rotate it. So when I rotate, this point comes over here. When I rotate it like that. And this point, I can take care of it where it will go by looking at this. This 4 goes at 1, 2, 3, 4 over here. And this maintains its angle. This point maintains this perpendicular. If I draw this perpendicular line, this should maintain that. So it ends up here. Yeah. And this point 2, where it touches 0, comes here. And so this 0 is mapped here. So I can then draw this. It takes this form. And you can again draw this 45-degree line. And it's kind of a flower, 2 flowers coming out of it in opposite direction. So it's symmetric around this line. So this is F, and this is F inverse. Let's do some practice with log. I don't know if I should do it. Most of you are quite aware of it. Let me just do one example. 7 or 8, whatever it is. Find exact value of, this is log. When I write 2, then I know that I'm talking about log to the base 2. And what do I mean by log to the base 2? As I defined in class, that log to any base a is inverse function of exponential to base a function. That means if you have this function, then its inverse function will be called log to the a. And since it's inverse, this is how you define it. It is that function with whose composition will give you x back. So that means I apply f first, and then I apply this function to this. I get x back. And because of this property, that composition in either order is identity. That means if I apply this function first and then apply a, which takes it to the power of a, this is also x. So that means I can define it with any a, and over here I'm defining it for the a equals to 2. So if you want to find this value, I'm just going to use the logs property that if you have a minus, that means a plus means you can write it as a single log with a multiplication, and a minus means log, single log, and this number becomes a division. So this gives me, I can solve 2 times 4. So it's log 2 to the 3. And this is the formula. So it's equal to 3. No. Maybe this is a little bit interesting. Consider this. So suppose you're given this function. And you want to sketch this graph. So when you are sketching, then, well, you can start from the graph of log x. So I'm sketching. which is touches it here. Goes like this and keeps going down. And it's a -1, so you have to shift it here. So it will be shifted like this. And then you pick it up. So this point goes up here. Looks something like that. So you know the general shape of it, but now it's kind of confusing that where does it intercept the x-axis? So it would be a useful information for the shape of the graph and for the sketch of the graph. These kind of things are kind of important. So you can put it as a question. What is the x-intercept? X-intercept means y is equal to 0. X for which y is 0. So you have log of x minus 1 minus 1 is 0. So this gives you, you want to solve for x. So you just raise to the power both sides to the e. And you can do that because you know that exponential is a one-to-one function. So e raised to the power 1 is e. On this side, you get x minus 1. That means x is e minus 1. So 2.71, you get 1.71 something. So it was around 1.7 something. And that's what our eyes were telling us, kind of. E plus 1, yeah, sorry. Plus 1. Now, let's consider, yeah, so there is this point. So suppose you want to solve the inequality. And the inequality given to you is this. Ex is greater than 5. Now, if I'm given some inequality, like a is greater than b, and I have a function, you are given a function. Function f. So apply f to a and b. A and b, given that they are both in domain. If I do that, I get a number f of a, I get a number f of b, but I have no right to say that where the f will drop the number a is going to be greater than where it drops the number b. Where it maps a and where it maps b, they in general will have no relation to what was the inequality between a and b. If a was bigger than b, f of a could be smaller than f of b. So I have no idea. in general. So this is not true in general. However, if f is an increasing function, if you look at the graph and it just keeps increasing, then if this is A, this is B, sorry, if this is B, this is A, and A is bigger than B, then that's the very definition of increasing functions, that f of A is going to be bigger than f of B. So for increasing functions, you can do that. In case of an increasing function, A bigger than B implies f of A is bigger than f of B. And you can very easily see, in case of decreasing functions, A greater than B will imply f of A is less than f of B. Now, if we look at the graphs, and it's just a property of these guys, graph of E of x is like this. So E of x is an increasing function. Similarly, graph of log of x is also an increasing function. Therefore, on this inequality, if I feed those two numbers, E of x is always in the range of log, because E of x is always a positive number and 5 is obviously positive. So both numbers are in the domain of log. So from this, I can feed those two numbers to the log function, and I'll still have this inequality. But this then gives me x is bigger than log of 5. So I have solved the inequality. Similarly, you can do this one. Let's consider this one. So I can apply the log. And the inequality signs remain, because log is increasing, and log of 1 is 0. So 3x is bigger than 1 and less than log 2 plus 1. So x is bigger than 1 by 3 and less than log 2 plus 1 over 3. Similarly, we can start from, let's take this one. So I have minus 2 log of x is less than 2. I divide by 2, I get minus log of x is less than 1. I multiply by minus 1, the inequality flips. Now I raise it to the power e. So x is bigger than 1 over e. That's the solution. Now we can do some finding domains of log functions. And finding inverse. So suppose you are given this find domain and inverse. So for domain, log must be fed something bigger than 0. So ex minus 3 has to be greater than 0. So ex is greater than 3. And that means x is greater than log of 3. That means the domain of f of x is x such that x is greater than log of 3. And if you want to find the inverse, just write it like this and solve for x. So I take e to the y, e cancels the log, I get ex minus 3, e to the y plus 3 gives me ex. Now I take the log, x is log of 3 plus ey. That means the inverse function is log of 3 plus ey. And here you can see that the domain of f has now become the range of f, because e of y will have value minimum 0. So g of x will start from log of 3. Ex, yeah, thank you. What else? Let's I think let's stop it here because everything else I can think of is pretty similar. So let's stop here. Unless there's a question or anything you want me to do.
Khuda Hafiz, sir.
Okay, Khuda Hafiz.